Okay, welcome into this final video. Let's put this up so maybe you don't hear the computer going. Let's go ahead and jump into it. So we have polynomial long division, right? So let me jump over to my whiteboard. All right, I already got it all written out for you. And let's jump into it. So the question we keep asking ourselves, right, if we have a 3x, is what number or what value times 3x will get me a 12x cubed? In this case, right, 3 times 4 gets me the 12. X times x squared gets me the x cubed. And so now I put my minus sign and I subtract the 12x cubed that I just found, right? 4x squared times 3x. But also, don't forget, we also have to do 4x squared times -1. So we have a minus 4x squared. We perform our subtraction. These should cancel out. That's exactly the reason why we pick 4x squared. And now be careful with the signs. We have 8x squared minus a negative 4x squared, or 12x squared. And we should drop down a term here. And now we're just going to repeat that process again. We ask ourselves 3x times what will get me 12x squared now. And that's going to be another 4. But now it's just going to be an x, right? And then I do the same process. Subtraction, parenthesis. 4x times the 3x is the 12x squared, right? That's why I chose 4x. But don't forget about 4x times -1, so minus 4x. We subtract again. If we've done this correctly, they cancel out. We have 11x minus a negative 4x, 15x, and this 10 comes all the way down, minus 10. And so we still have one more to do, right? So now we're asking ourselves, this 3x times what will get me a 15x? In this case, just a plus 5. And so last iteration of this, we subtract out. We have our 15x that we found, right, from the 5 times 3x. And we also have 5 times -1, so minus 5. We subtract out, and our answer is -10 minus a -5, or -10 plus 5 gets me -5. So my quotient, I'll just put Q for quotient, is 4x squared plus 4x plus 5. And my remainder is just going to be -5 over, I mean, it doesn't ask you to put this, but it is technically over the 3x minus 1. But you just have to type in the -5. So take a second, pause. I know I went through that quick, so don't feel like you can't actually stop and redo it. Not expecting anyone to do it that quick. Take your time. All right, this is number 14, the factor theorem. So it says, use the factor theorem to determine whether x plus b is a factor of p of x. Okay, now the way that we do this is that if we have an x plus 3, that would mean that when I plug in a -3, I should get a 0 out. That's what it means to be a factor, according to the factor theorem. We can plug in the -3, right, and I will get a 0 out. So if I plug in -3, right, we'll do some side work. Let's go ahead and write this down, 2x cubed plus 5x squared plus 9. Okay, and we're plugging in -3. And so if we get a 0, then it's a factor. If we don't, if we get anything other than a 0, not a factor. And so let's see what happens. We have 2 times -27 plus that would be -3 squared is 9 times 5 is 45 plus 9. It looks like, right, -54 plus 54 is going to be equal to 0. So check mark, it is good. This is indeed a factor because we got 0. So it is 0, which means x plus 3 is a factor. Okay, moving forward, let's do another one. Okay, 15 is finding all possible rational zeros using the rational zeros theorem. Right, so maybe we need to remind ourselves of what that theorem is. So go ahead, write down this h of x, and I'll meet you at the whiteboard. Okay, so let's remind ourselves that the factor theorem is going to be the divisors of a naught divided by the divisors of a sub n. And we're going to add this plus or minus before it. So a naught here is -4. Right, so let's actually do this first. I'll just label what a sub naught is. Now because we're putting the plus minus, the negative doesn't really matter. And so our divisors here, right, we'll put our plus minus now. Divisors of 4 are going to be 1, 2, and 4, and divisors of 10 are going to be 1, 2, and 5. Right, and this gives us all of our possible rational zeros. And so let's go down the list, and we want to make sure we don't have any repeats as well, and you'll see what I mean by that. So we have plus or minus 1, right? So 1 divided by 1, which is 1. We have plus or minus 1 divided by 2, 1/2. Plus or minus 1 divided by 5, 1/5. And let's move over to the 2. We have plus or minus 2, right? 2 divided by 1. And then we have plus or minus 2 divided by 2, but 2 divided by 2 is 1, so we can skip over that again, or skip over that for now. Then we have 2 divided by 5. And let's see, plus or minus 4 divided by 1. Now 4 divided by 2 is also 2, and we already have a 2, so we're good. And we have plus or minus 4/5. Right, so we have a total of 7 answers here that you would want to type in. It does give you the nice plus or minus symbol to put in and Alex, so please do remember how to do that. Let's see if I can drag it over here. Nope, not that way. All right, so we can see there's a plus or minus symbol. I don't have these in front of us, but just so you can see, right, 1, I think there was a plus or minus 2, plus or minus 4. What else did we have? We had a plus or minus 1/2. We had a plus or minus 1/4, I believe. Not 1/4, sorry. We had 1/5. We had a plus or minus 2/5. Oh, did I forget the 10? I forgot the 10, didn't I? Let's go back. Oops. It happens. That's what happens when I'm going too fast. Right, you're like, what about the 10? Here's a 10. Which means, I caught it, luckily, plus or minus 1/10. 1 divided by 10. Now the good news for me is I really only missed that, right? Because 2 divided by 10 is going to be, again, 1/5. And 4 divided by 10 is going to be, again, the 2/5 that we already have. So I only forgot 1, but still, we do need that one. So we should have 8. I think it was plus or minus 4/5. And plus or minus 1/10. How many do I have here? Am I close? I think that's all of them. Uh-oh. Should be commas. Did I forget some commas? Comma, comma. Here's a comma. I'm making all the easy mistakes for you. Did I get them all? I did. Okay, good. All right, so 2 more problems to go.